I'm sorry. Go ahead.
This can't be good. If you give it to the next guy, he's like, I don't know what to do.
You want a beer?
The Devshop is live streamed and recorded. Occasionally in the live shot, you'll see part of the audience like a display if you're self-conscious about being on camera. That would be the time to like go towards the back or the front. We don't care to say, but alright, that's all.
Hello, everyone. Hey, everyone. Talks are going to start in about 10 minutes, so if you wouldn't mind grabbing a seat. We have some seats available interspersed up in front here. So yeah, grab a seat. That way you'll be able to make sure that you have a seat to get to later. Hey. So So feel free to grab some seats. There's some more up here. Yeah. Hey, Alice? I More like 2. You have a seat already, right? Okay. Yeah.
I see. You're like, oh, this could potentially help early variable by
Hello, everyone. Please grab a seat. We are about to start very shortly. Hey, Tom. Hello everyone, welcome to Devshop. We have a couple of seats up in front, so those of you who are standing in the back, there's room for you right up here. Our first speaker today, Tom Coleman, probably doesn't need this introduction. He runs Percolate Studios, which is the group that brought you Verso, which is in the App Store. He's one of the authors of Discover Meteor, and some of you have picked up Discover Meteor shirts today, so you guys are rocking it. And today, Tom is going to give you a 2-year retrospective of his time developing apps with Meteor. So, real time flies, 2 years with Meteor. Tom Coleman.
Thanks, everyone. Yeah, so as Jade said, I'm going to talk a little bit about my and our history with Meteor and how, I guess, developing Meteor apps has changed over the period of the 2 years that we've been doing it. So, as Jade said, my name's Tom Coleman. Work with Percolate Studio and wrote the book with Sasha. So, this is a talk about evolution, about how things have changed. So it actually starts more than 2 years ago, in November 2011, when 010 of, it wasn't even called Meteor at that point, Skybreak appeared. I didn't know about it at that point, but I guess that's where the story starts. In January 2012, the name Meteor was officially coined. And what were we doing? Well, we didn't know about it. We were building an app called Bindle, which was a Rails app. We were a Rails shop. We loved Rails. We loved Ruby. But we kind of built this app Bindle, which was really front-end heavy. It wasn't quite a single-page app, but we were doing a lot of stuff in JavaScript. And we're finding it quite frustrating constantly moving between Rails and JavaScript. We also had this chat component, which wasn't at all real-time. As a startup, we didn't really have time to do it. We could probably have done it with Rails, made it real-time, but it wasn't a priority. So it was kind of a crappy UX. Meanwhile, in early 2012, while we were doing this, Meteor was barreling through versions. I looked up the version history, and they got through quite a few in a few months. But eventually, we heard about Meteor. We wanted to give it a try. So we decided to build a little example app in it. So we had an idea for League, which was a sports management app for sort of small teams. And so we went ahead and we built a little app with Meteor called League. It was kind of cool. It had Facebook integration. It had some animations, as you saw. It had a little date picker here. And it was really fun. We really enjoyed it. We thought it was great, but some things were pretty hard. Doing the authentication with Facebook was a pain. Using that date picker didn't really work properly. The transitions were a major challenge. And also we built a little router package, which we wanted to share with everyone, but there wasn't really a way to do it. So the next thing that happened with Meteor and us, or me personally, is Meteorite. I got together with a guy called Mike Bannister, and we built a little package manager for Meteor. Meteor didn't have a package manager, so we just built one. It enabled us to share our router packages and our other packages with each other and the world. In August 2012, 040 came out with Spark, which, although it didn't completely solve the jQuery UI problem, it made it a lot easier. And it made a lot of templating stuff much, much easier. So when it came time to build Atmosphere, which was the website with the package repository for the packages that we built with Meteor, it was a lot easier. In fact, building the Atmosphere app was pretty straightforward in many ways, and it was a pretty straightforward app. I'm sure a lot of you guys recognize this awesome UI. Atmosphere was lived in this form for a year and a half, and it did the job while there were a couple of hundred packages. When it got to 1,300, it started to be a bit silly to have a list of all the packages that existed published to every client. One thing that was difficult with Atmosphere was validating the data that came in, making sure that people weren't publishing the wrong fields on their packages and stuff. And that was a challenge that we found, but in general, it was a lot easier with Spark. In October 2012, 050 of Meteor came out, and this was a huge deal. So when Meteor first appeared, there were a lot of people criticizing it, saying Meteor is not secure. The other big criticism was that Meteor doesn't scale. But Meteor is not secure because it publishes all the data to the clients, and the clients can make essentially Mongo calls in the browser. And so when 050 came out, really the tables were turned, because now authentication was built into the framework. There was no way around it. Doing something like a Facebook integration, which we'd slaved over, suddenly became trivial one line of code, which was cool. Still, we were struggling with structure of the apps as well. And in November 2012, I got together with Sasha, who I'm sure most of you are familiar with, and we built a little app called Telescope. Sasha was really interested in building a Hacker News clone that was real-time. Meteor was a great technology to do it with. And so we built this sort of reusable app called Telescope, which you can use. It's open source. You can use it for any kind of chat site, social news site that you like, where you'd like to share links with each other and chat about them. And it was pretty cool. We could use packages for it. We started to have an idea about a lot of the ways to solve some of the patterns that we didn't really know how to do early on with Meteor. And it was pretty fun building it. We had some interesting user interface challenges, like how to deal with reordering lists when the reordering potentially happens from someone else, how to communicate that to the user, how to deal with new comments appearing in a feed without disturbing the comments that the user's currently reading. And we had some fun playing with that. There were some things that were still difficult. Doing the publications and doing the pagination of data was a challenge. But I guess we learned a lot by building Telescope. And we decided to write a book about it because a lot of people were asking us how to do various things, and we were answering the same questions over and over again. So in May of last year, almost a year ago exactly, we launched the Discover Meteor book and shared what we knew with the world. And that was great. In August 2013, 065, which was a fairly significant release that didn't get its own version number of Meteor, came out, which changed package namespacing. And this was quite a big problem. A lot of packages broke, and it was a bit of an issue, but it was a hurdle that had to be passed. So that was worth mentioning. In September 2013, Percolate Studio released first sort of big Meteor app, which was Verso, which is a mobile app that we built with our partners at Learnology. And it was a phone gap app, so it runs in the phone browser. Not in the browser, it runs in an app in the App Store. It had a lot of complicated transitions. It ran smoothly on phones. It does a lot of stuff. And we demoed it about 6 months ago here at Devshop. And yeah, it was a really, really successful experience. It was a great pleasure building a much more large, complicated app in Meteor. We really had to solve a few things along the way, but we did, and we were very happy with the result. The challenges were, of course, achieving the mobile user experience, which is tricky in HTML in general, and Meteor being a web technology, that's obviously what you need to do. But we started to find solutions to the problems of structure and validations, and it was really interactive. Obviously, the real-time nature of the app made it great for students and teachers. We found that students and teachers were using it in a way that it wasn't expected. They were using it to chat to each other in class, which wasn't really what it was for, but the real-time nature of it made that fun for them. So it was a cool little app, and it still is. It still exists. In December last year, 0.7.0 of Meteor came out, and this was a huge deal, Oplog. Oplog totally changed the game on Meteor and scaling. Until that point, the worries about Meteor scaling were semi-justified. We didn't actually run into problems with our apps, but we could have, I suppose. Certainly it was something that people were justifiably worried about, but I think with Oplog, we've seen amazing performance improvements, and the problem is more or less solved. In March 2014, we at Percolate got together to improve Atmosphere, which the old dated user interface had been sitting around for a long time based on the fact that we kind of thought it was going to go away. So we decided it was time for an overhaul, and we wanted to demonstrate a few cool things that you could do on the web, what you could do with HTML, and some cool reactive things that you could do, and we really wanted to explore the way that packages can be discovered. So we built Atmosphere, the new version, which is very much a work in progress. There are a lot of features that we are planning. Atmosphere, was on Blaze at this point. Well, Blaze hasn't been released yet in my story, but we were using a pre-release. Using jQuery UI packages, using third-party plugins was completely trivial. We had the structure of the app really worked out. We had the way to do publications really worked out. We had pagination worked out. And all in all, it was a very smooth process building the app. In March, Blaze was actually released. And Blaze is a real game changer because it really helps Meteor integrate with other JavaScript libraries. All of a sudden, Meteor plays nice. And it's really a lot easier to build complicated user interfaces leveraging other people's front-end code. Finally, just last month, we launched the beta of Meeting Hero, an app that we built with our partners at Heroic. Meeting Hero is an app to be used in meetings for recording things like agenda items and decisions. It is very much real-time, find it as you type real-time. And thanks to Blaze, thanks to Meteor, the in-meeting experience is pretty cool. You can drag items between lists, you can see who's typing, you can watch them type, and you can be way more productive in meetings. So, well, what's the point of the story? The point of the story is we've come a very long way. When we started and we built League, it was fun. We love building apps with Meteor. Getting real-time for free was awesome. Only having to work in one language and having the nice APIs that Meteor gives you was incredible. But there were a lot of rough edges. And perhaps the story isn't completely finished. Perhaps the line should continue on to the right. But I think we're at a point now where the pros massively outweigh the cons. And so many things have become so much easier that it's really a constant pleasure building apps with Meteor. So I'll just skip that. So what's next? Well, we know the big feature that Meteor development group are working on before 1.0 is packaging. We'll finally get rid of Meteorite, the little hacky node script that me and Mike built almost 2 years ago. We'll finally have a way for packages to report which versions of Meteor they work with. We'll have a proper way of updating dependencies and not having to update them all. And we'll have a package server that is way more reliable and hosted by someone whose job it is to look after it. So that's going to be great. I think it's going to really help people share packages. We hope with Atmosphere to make it a lot easier for people to find packages. And the other big feature that we're sort of working on at the moment, and perhaps will make its way into core, is animation support. I think it's really important. As you've seen with our apps, we really make heavy use of transitions. We make heavy use of CSS animation and transitions, and we'd like to make further use of SVGs and animating things around to really achieve that native-like feel on mobile browsers, and just to bring the web experience to the next level. So I think there's a lot that Meteor could do to help with that. Thanks very much.
All right, questions? I have a question. Is Meeting Hero something that, that people can use right now?
It's in private beta, so you can go and sign up to get on the waiting list. But apart from that, yes.
Will you be doing adding to the Discover Meteor book with what you added with Meeting Hero? Will you do like an open source project version of that, or like you did with Telescope?
So the question was, will we be adding to the book with what we've learned from Meeting Hero, and we'll be making some code open source and available? So I guess we'd definitely like to share that knowledge. Telescope was built from the beginning as an open source app, so it was very easy to sort of rip parts out of it and make Microscope out of it, which was the app that the book was built off. Meeting Hero, for instance, is not an open source project, it's a client project. But we'll certainly be expanding the book. We'll certainly be adding more chapters. We'll certainly be adding more content, I think, as Meteor moves past 1.0. So a lot of that will come through. I'm not sure exactly what code will appear. Probably just more Microscope code. Yeah.
Now, to be on mobile, do you need a constant internet connection, or once it's
So the question was, on mobile, do you need a constant connection to the net, or can you use the app completely without a connection? The answer is much closer to the first than the second. It sort of kind of works without an internet connection, in that if you're on a given screen, you can kind of move around, but if you ever need more data or try and write to the database, it's not going to work. So there's no sort of concept of a local database that is kind of like a cache of the real database. I know that there's been a long-running project working on that, and I think that's the sort of thing that will make its way into core eventually, and then that will make the mobile experience on Meteor that much better, but I think we're a way away from seeing that.
I have another question.
Yeah.
How did you make the animations in your slides?
You'd have to ask Dom about that. I'm not sure. He's not even listening. He's a Keynote expert.
Cool. Any other questions? All right. Well, if you haven't gotten your Discover Meteor shirt on your way in, we have them in the lobby, and we'll be taking a bit of a break until 7:30, which is when our next talk will be. All right, so we have bathrooms here and right behind that wall and in the lobby, and also feel free to grab beverages that are up here. So.
Thanks a lot, everyone.
Cheers.
When are you guys doing it? After the next talk? That's cool. All right.
Our idea is like you can say, even goes to 1.2.3, well, rectify that.
be getting started in just a second. I would like to get the attention of the Lightning Talk speakers. So if I could get 6 people to go back there and find where Bill is. Justin Santa Barbara, Steve Cannon, Tim Haynes, Josh Owens, Dan Doskalescu, and Mina Mikhail. So if the 6 of you could, oh, Justin, you've already been mic'd up, right? So you're fine where you are. The rest of you, if you could go back there, and Bill will be ready to mic you up. Thank you. All right. I prefer here, but you could use a podium if you prefer it. Do you prefer it?
I would like to make it easier to read my notes.
Oh,
The main thing I want is the podium.
yeah.
Yeah, they'll adjust for you.
Pardon? Yeah. So let's face that at you. All right. All right, our next speaker, please grab a seat. Our next speaker is Geoff Schmidt, one of the founders of Meteor. And today he is going to be telling you about the technologies behind Meteor.
Hey everyone, so some familiar faces, some new faces. Raise your hand if you've been to Devshop before, if you've come to one of these events. All right, so that looks like about 2/3 of the audience. So we're gonna do a run through here, and we're gonna talk about, what is Meteor really? And let's talk a little, we often get really far down into the details, but let's talk a little bit more at a high level about what we're building, why, where it's going, and like what the big pieces of it are that like make Meteor what it is. So the first thing I want to point out is there's a lot of frameworks in the world that we're used to using, things like Rails, Django, Spring, ASP.NET. Frameworks, they provide some scaffolding, some structure when you're building an app to make it a lot faster and easier to build apps. They take out a lot of the choices that the uninteresting choices that you might need when you're building an application. Meteor does all those things, but Meteor is also something more than a framework. Meteor is a platform. And when we talk about platforms, we think about something that's larger than a framework. We think about a whole technology base, a whole set of allied technologies that go together to be a way that we build apps. So these are things like Unix, or Windows, or Java, or the LAMP stack, the MAMP stack, all the different LAMP-like stacks. I call that hypertext, the 90s web. So what makes up a platform? Like let's sort of, what do we mean when we say that Meteor is a platform? What are some other platforms? Well, some other platforms we've had in history, well, Windows, Windows is a desktop platform. If you want to write software that runs on a personal computer, you could use Windows. And Windows came about in a time when everyone was starting to have personal computers on their desktop, but it was very hard to program for one of these computers. Like you had to build everything from scratch if you just wanted an application that ran on your Apple II or something. So the genius of DOS, the genius of Windows, was that it provided all the technologies you needed to build a really compelling app that you could take to these personal computers that were starting to proliferate. So if you look at what's inside the Windows platform, there's a lot of pieces that come together to make that platform that you can build software on top of. That's everything from the whole idea of like an EXE or a DLL, like the file formats that underpin that, to the kernel that runs those programs, to the developer tools like Visual Studio, ways of drawing on the screen like GDI or WPF, ways of talking to other processes like the component object model, DirectX for rendering 3D graphics. These are all the different parts that happen over there in Dimension Microsoft, so you can write some great software that runs on a PC. or that talks over the network to build a client-server application like a lot of people did in the 80s and 90s. Or we could talk about Unix. You know, there's a similar set of things that go together to make up Unix. You've got build tools like make, you've got a kernel, you've got a compiler, you have things like sys5 sockets for talking over the internet. Now it's such a good idea, it's spread to basically everything now. You've got package systems like RPM or dpackage. And then, you know, if we think about a platform that probably more people, or many people in this room are really familiar with, it's like the hypertext platforms from the web that we built in the 90s. So this is, if you look at what a modern app written on top of this, these hypertext platforms look like, you've got Nginx, you've got Postgres, you probably have a framework in there like Rails or Django. You might have Apache or Memcache, lots of different options for these technologies. But that's the web platform. And when we say the web platform, I say hypertext instead of web because we reached a point in history where we need to be a little bit more specific. Because there's the platform that the web used from around 1994 and 1995, up to, I don't know, a couple years ago. And there's the platform that most of us are building our apps on top of now. And this new platform, it's got things inside of it like Angular or Sock.js, or Node.js. It's really different from LampStack. It's really a whole new platform. And so what Meteor, and it's interesting because it's a much less mature platform. We're at an interesting turning point in history where it's like it's 1994 and we're writing web servers in C. Everyone knows that we want to get these applications out there onto this World Wide Web, but the technologies aren't that mature. It's not really clear how they should all fit together. And we have to do, if we want to build one of these applications, we have to roll a lot of things ourselves. And some of this, sometimes you can do this by fitting together open source components you find and like having to do a lot of experiments yourself to figure out really how it works, design your own architectures. Sometimes you really do have to build some really difficult and tricky components from scratch. So with Meteor, what we're really trying to do as a community is we're trying to build the first client cloud, we call it, platform. Just like how Unix was a great platform to use on time-sharing systems, and Windows was a great platform to use on PCs, and the LampStack was a great platform to use to deliver customizable hypertext to millions of people at once. We're trying to build an open source platform for this new, call it client cloud era. So client cloud, what's that? Well, here's roughly the progression that application platforms have taken over the last, well, as long as our species has been experimenting with computer applications. First, there were mainframes. And then there's a big change. We all went to client server. For applications that talked to the network, that worked with data, we had the client server era, where we had these PCs that talked to services in a data center somewhere. And then there was another big revolution, and we went to the web, the web of hypertext. And now something new is happening. We're moving to, it's as big as a transition from mainframes to PCs, or from PCs to the web. It's a transition from the LampStack to this new way of writing applications. So what is this new way of writing applications? How is it different from the web we had before? The big difference is the devices, like it's not just a smart server and dumb clients, it's actually a distributed system. So we have supercomputers in our pockets now. They're called iPhones. And also, when we talk about the server side is different too, because when we thought about building client-server applications in the 80s and 90s, and that was really the last time we had smart devices, we had PCs. At that time, we still thought in terms of servers that go in a rack somewhere. But now when we think about the services our apps talk to, we're actually thinking about distributed services that exist in the cloud, that are spread over multiple data centers, that are highly available, that have to synchronize between different regions. And I think if I were to summarize what the big points of these new kinds of applications we're all trying to write are, you could say they're reactive, distributed systems that run on diverse architectures that put data on the wire. So let me go through those things one at a time. So by reactive, what I mean is, generally what happens is, it's not I do a query and I get back a response. It's something changes in a database somewhere. Then we need to respond to that event that happened. And we respond to that event by finding all the clients that are affected, whether that's tabs in a web browser or mobile devices, and telling them about the change. And more people are starting to talk about this paradigm of reactive applications. It's a great web page, if you haven't seen it, the Reactive Manifesto, that is more coming out of the Java community, saying, OK, when we think about our services that we're building in our data center, we need to think about these applications as being reactive. So Meteor is reactive from top to bottom, and just about any client cloud framework has to be. And that's not because we really need to have our stock quotes update immediately. It's not about real time. It's about the fact that we actually have to synchronize. It's about the fact that we're in a distributed system. Like, our applications are actually running in this web browser. They're running on this mobile device. So when a change happens, we have to push the changes down to them just to keep them up to date. In the hypertext world, we didn't have to do that because we had page reloads. You had to reload a page if you wanted something to change. But since we don't have page reloads anymore, we have to have reactivity. We have to proactively push these changes down. We have all the problems that distributed systems have. And when you think about a distributed system, the thing is, all the clients are now nodes in the distributed system. So your web browser is a node. If 1 million people are using your app right now, each of those people is a node that has to be informed of changes. Every iPhone out there, every Android phone out there that has a cache of some data on it is a node in this distributed system. And many of the same problems we have when we think about distributed systems on the server, suddenly we have in keeping all these clients up to date. And the other thing is, we think about this distributed system, all the nodes in it. The nodes, they have a lot of different architectures. So when we think about architectures, we're used to thinking about, oh, Windows architecture, Linux architecture, Intel architecture, PowerPC architecture. But now we have a whole other set of architectures called like the W3C architecture, like the HTML5 architecture. JavaScript is turning into bytecode, kind of like JVM. You can write your app in CoffeeScript. You can write your app in TypeScript. And like, it's just like writing your app in Scala versus Clojure versus Java and running on the JVM. You know, really, browsers, this HTML5 world, have turned into a compile target. And we should treat them just like the other compile targets we have, just like PowerPC or Linux or Windows. And finally, the other point is, these client cloud applications, they put data on the wire instead of presentation. So the 90s web put presentation on the wire. We just send HTML around all the nodes. But now we do something different. We send data to the nodes. And that's because we're doing the rendering down there on the client, because it gives you a better user experience. It gives you those animations. It gives you those nice pop-up dialog boxes. It gives you not requiring people to reload the page when something else happens. That means we need to send data around instead of HTML. So this client cloud world, this is the world of HTML5 as a platform that you can run your application on top of. This is the world of mobile. Mobile devices were always part of the client cloud world. This is the world of AWS and other cloud infrastructure providers where your app is actually distributed all over the world on these boxes in the cloud. This is also the world of the Internet of Things, because you think about 1 million users accessing your app simultaneously as being a lot of nodes in your distributed system. Wait until we start talking about all the sensors that are out there in the world as we start to actually instrument all the things in the world and make that part of our application too. OK, so don't have a lot of time today to go through in detail how the Meteor platform works. But I'm going to skim through, we see here like the technologies that make up Meteor. Skim through that really quickly just to give a sense of what a modern client cloud platform looks like and the direction that we're going with Meteor to try to develop the best and really first open source client cloud platform. So one of the core technologies inside Meteor is we don't really have it a name yet. You know it because you type Meteor bundle or you type Meteor and it just works. But I think we're going to come up with a brand for it. Probably going to be something like Unibuild, Unipackage. It's Meteor's build system. So it's a tool like Make or Sconce. It's a build tool. And the really cool thing about this build tool is you start with one source tree, one source tree of your application, one package system, and you can target. You can from that one source tree, you can build for multiple programs that are going to run on different nodes in your distributed system. So in Meteor today, you see that because you have a server program that runs on like Linux, and you have a client program that runs in the browser. But really what's going on here is this is a distributed system build tool. It's a tool that understands we're going to have one code base that might be written in multiple languages. Then we hit build, we get multiple build products that then go different places. They go into the Apple App Store. They go into your web browser. They go into an Arduino in a sensor. They go into AWS or Azure or Rackspace, like to run in the cloud. And so there's, and it's really cool that we can have one package system where you can share code between all these different deploy targets. And it's really cool that we can provide all the things you'd expect in a build system, like source level debugging, for example, with source maps. So to get a sense of where this is going to go in the future, imagine what it's like if you can write part of your app in Clojure, and then have, when the server part of your app, that Clojure runs on top of the JVM, and the client part of your app, that runs with ClojureScript right on top of the JavaScript VM. Or imagine you could write part of your app in C, and on the server, that's native code, and on the client, that goes through Emscripten and asm.js. The point is, what we're really trying to do when we write these applications is we want to have one code base, multiple languages, multiple targets, multiple architectures. So next thing to talk about. So DDP, I said we need a protocol for delivering data in this distributed system. So the protocol we used for the web, excuse me. For the web, we had HTTP. And that was a great protocol for delivering hypertext, delivering these cacheable static assets. But what we're seeing people do today is we're building apps that don't need to deliver hypertext. They don't need to deliver static cacheable assets. They need to deliver data. And they need to synchronize this data between all the nodes in the distributed system. And what everyone's doing is they're building their own custom protocols that are basically the same, but the messengers name something different in everyone's implementation, so they're not interoperable. So all we need to do is we need to take these custom protocols that everyone's building on top of WebSockets and on top of long polling and standardize what we're going to name those messages. That'll give us interoperability. Why is that important? Well, we got a lot of great things from HTTP when it comes to interoperability that we've lost with this forest of custom WebSocket protocols everyone's building. And we can get those back by using DDP. So we can have shared tooling. So in the world of HTTP, we can make these caching proxies. If we all use the same protocol like DDP to synchronize the data, we can build caching proxies for the data that we're delivering to our applications. One person can write that caching proxy. Then anyone who's trying to synchronize data from a server to the client over a WebSocket can use that caching proxy. We can have interchangeable parts. You can have a different framework on the server and on the client. And people are doing this with Meteor today. They write their server in Java. They use the Meteor tool set for the client. Or they use the Meteor JavaScript stuff on the server, and then they write a native iOS client that talks to it over DDP. The other thing is APIs. When's the last time you saw an API that ran over WebSockets? You know, you'd think we'd have these all over the place because we want to expose these awesome real-time services we're building, but it's just too hard to specify those APIs. So we need something where the specification for an API for one of these great real-time services everyone is building fits on a page. So this is all possible with DDP. Livequery. So this whole reactive system isn't that useful if you don't have any way to get reactive data out of your database. So Livequery is an alien technology that turns your database into a reactive database with streaming queries. So in other words, instead of just saying, you know, select star from people and getting all the people in the people table, I can say, select star from people. Don't just give me the results once, but stream the results to me. Like whenever new rows are added or removed or when they change, send me those updates. Give me an update stream for an arbitrary query. So that's, and so we have that for Mongo right now. And it's implemented by connecting to Mongo as a replication slave. And of course, just like with any database query, some queries are efficient, some queries are something other than efficient, and you have to do some thinking about what things are safe and performant, and you know, database optimizers can improve over time. But there's nothing fundamentally tied to Mongo about the Livequery approach, and I think we even have an exciting lightning talk tonight about some more directions here, but we'll be starting soon on SQL. Deps. The unsung hero of Meteor client-side programming. It's a library for transparent reactive programming. So it's incredibly tiny. It's about a kilobyte, but incredibly powerful. So Deps takes your normal JavaScript code and makes it magically become reactive. So you know, if you've been using Meteor, you've probably been using this and haven't even thought about it. So here's some code, and it's a function called selected person name, and it just returns the name of the currently selected person in uppercase, or nobody if no person is selected. But you know what? In Meteor, this is reactive code. It's automatically reactive, transparently reactive. Meteor, using deps.autorun, you can call this function, get the currently selected person name, and get an update whenever the output of this function changes. Whenever the current selection changes, we'll get an update. Whenever the name of the selected person changes in the database, you'll get an update. And when these updates happen, the value is transformed by going through to uppercase. And this is an alternative to, in other systems, you might have to do polling, you might or dirty checking. You might have to wire up a whole bunch of events to listen for a selection change event, a first name change event. Or if you're using a functional reactive programming system, you'd have to create a bunch of nodes and chain them together, like a node that represented the selection, a node that represented the, getting a person from the database, and a node that represented putting in an uppercase. You have to chain all these nodes together. But with deps, you can just write arbitrary JavaScript, and it just works. All in 1 kilobyte. What a deal. Blaze. So Blaze is a library that works with deps to do reactive DOM updates. So Blaze is another amazing, a lot more complicated than deps. But you just write a familiar looking template, in this case in handlebar style, and this template automatically updates live. So when a new person is added, there'll be another element added to the list. If the first name or the last name of a person changes, it'll change in place. We're calling our selected person name function that we defined before here. All of these, Blaze will find a way to patch just the part of the DOM that's changed and keep this in sync, replacing what would have had to have been a lot of logic to rifle through the DOM, find the right nodes, and make the updates. So there are other libraries out there that provide the same sort of kind of reactive DOM updating, and compared to those, the big things that Blaze gives you are, it doesn't have any kind of DSL or directives that you need to use that are special, and it's also template-based. So you don't have to write JavaScript to construct the page. You can just write a template. And people have different preferences for how they want to write their front-end code, and so you can swap out Blaze for Angular or React or whatever library you prefer, but we found that a lot of people really like this very simple way to just write a template and with no extra work have it become reactive. So I think that looks like I have no time left. So if you are interested, I encourage everyone to come check out David Greenspan's talk about Blaze tomorrow at HTML5 DevConf if you're coming, which will be a much more in-depth introduction. Sorry? Oh, sorry, excuse me, Thursday. Over the next couple months, we're going to be producing some much more in-depth content about each of these parts of Meteor and going into how they work, not just on the level of a slide, but full detailed information about how these parts fit into this client-cloud architecture of the future and how you can use them either with Meteor or independently. In the back.
DDP is great for these sort of high volume connections. What about long life, low volume connections that kind of like webhooks and all are probably better for?
What about, so the question is, so DDP is great for a high volume interactive session where I'm logged in, I want to keep the page up to date. What's the solution for, let's say there's an API, if I have this right. There's let's say I want to monitor someone's Facebook page and get called back when they've changed their job on Facebook. Could DDP be the API that Facebook uses to expose this instead of webhooks? The answer is, so DDP is designed to, right now, DDP is, right now when you disconnect from a DDP connection, the server forgets the connection state. But there's actually a protocol feature for DDP that's designed out so you can actually shut down that DDP connection and then reconnect later and resume your subscriptions where you left off. So that's useful in 2 scenarios. One scenario that's useful for is power saving on mobile. So for mobile, you might want to not be connected all the time. You might want to connect, get some updates, and then drop the TCP connection to save some battery. So then the question is, how do you know when to reconnect and get some more data? And a related question is, you might be monitoring lots of things on the internet that change very slowly, like only once or twice a year or once or twice a month. In that case, we might also think about dropping the DDP connection and wanting to get a callback. And so the idea is that, though this hasn't been implemented yet, the idea is DDP will have a way to quiesce a connection and say, here's how I'd like to be called back. So that could be with a webhook. That could be with a push notification on a mobile platform that has a battery-efficient way, a more battery-efficient way to deliver push notifications than you could deliver yourself. So yes, absolutely. On the roadmap for DDP is a way to quiesce a connection, whether that's for a minute or for 10 minutes because we think updates only come every 10 minutes and we want to save battery, or for a month because we think this is a data source that changes very slowly. And the DDP protocol was designed with that in mind from the beginning. Does that answer the question? Other questions?
We have a question from Twitter.
From Twitter.
What is the .star format?
What is the .star format? A .star is like a .exe except for loading into Galaxy. It's a little bit analogous to a slug on Heroku or a war or ear in Java land. So in other words, it's a bundled cloud service that you can go run. We'll have more to say about that when Galaxy is released.
In your list, you didn't say anything about fibers, and that seems like a pretty useful thing, at least for me, for programming, since it makes it a lot easier to program.
So the question is, I didn't say any in my list about fibers. Well, that's because I think everyone should be using fibers. I didn't say anything about oxygen or water either. Fibers are not the solution to every problem, but they sure do make it easy to write business logic. So the way I think about this is, there's sometimes when you're web building, it's something like a message bus, where you have a whole bunch of concurrent events that don't necessarily have a lot of state, or you can build the state machine around that and really model out what that state is. In that case, yeah, there may be situations where it's easier to think about that problem, especially if you want high performance, as a bunch of asynchronous callbacks and events. But I think in most cases, when people are writing complex business logic, where I want to talk to some servers and then do a thing and fetch something from a database and then do a computation, it ends up being much easier to write that code in something that looks a lot more like a straight line way. And I think some of the reasons why people, Node has trained people to worry about synchronous calls because if you're not using fibers, they block the event loop, and that's really bad. And the thing that's excellent about fibers is you can actually preserve that same coding style where you write a series of function calls and you're able to use the return value from each function call, and you have a nice clean stack, and you have events that propagate the way you expect. While not actually blocking the event loop, while still getting something comparable to the same performance. So yeah, probably should have been on the list.
Another question from Twitter. Daryl from Australia says, hi, Geoff. Can I make a DDP server in another language?
Absolutely. So do I need to repeat that question? Or you might?
I might.
OK. Yes, you can absolutely make a DDP server in another language. And I think there's something like a dozen independent implementations of DDP, not counting the one in Meteor core. So I've seen everything from, so there's a project where they have real-time financial data coming into their Java server, and they have their proprietary financial models that are running in Java, and they've implemented a DDP server so they can write their Meteor, they can write their client and their front end entirely in Meteor, and they just call meteor.connect to connect to that backend service. And even though this backend service is written in Java with no Meteor code, it speaks DDP, and everything on the page updates live. You can do it the other way around too, where you use the Meteor server and you make, let's say, a native mobile client. You write an iOS client or an Android client that just has a DDP library, and you can make those same live updating subscriptions and get reactive pushes of data from the server to your mobile device if you don't want to use HTML5 JavaScript technologies and want to go straight native. There's even a brain scanning microscope that uses DDP to manage all the processes that are involved in slicing a brain very thinly with a diamond knife, and then scanning all the brain slices, and positioning the microscope stage with nanometer accuracy. And so they wrote, and a lot of that is data acquisition is run by Windows boxes because the drivers are only available for Windows. So they have made that's all run by DDP infrastructure, including the image acquisition. And it's really cool because they have a Meteor dashboard, and you can see the current position of the microscope stage, and it's measured in nanometers, and it's fluctuating back and forth by a couple of nanometers in real time as it's like vibrations in the room. So yeah, the spec of DDP is just a couple pages. You can find it in the live data directory of the Meteor repository. It's not hard to implement at all. And we'll be doing more in the future to get that standardized and promoted a little bit more and start an active effort to encourage more services to be built on top of DDP post 1.0. What is Galaxy? So right now with Meteor, you can type Meteor deploy, and you instantly deploy your app to free hosting provided by Meteor Development Group. There's a quick, easy way to try out deploying a Meteor app. So Galaxy is like a much more powerful version of Meteor deploy. So with one command, you can deploy your app into it's like your own cloud hosting environment. You can think of it as like something like Heroku, except contains more Meteor-specific functionality. So functionality like being able to do hot rolling code updates. So when you deploy your app, doing seamless transitions for every client that's connected, or doing good DDP proxying, so it's easier to split load between servers. So it's basically our answer for what's the best way to do the DevOps for your Meteor app.
One more question from Twitter. Will it be possible to hook at Unibuild to customize Meteor's build process from a Meteor package?
The question is, will it be possible to hook Unibuild to customize the Meteor build process? I love these softball questions we're getting. So yes, the idea of Unibuild is it should give you all the power of a build system like Make or Scones, but it should be really easy to use. And the way that we've come up with doing that is the idea that packages in Unibuild can both contain code, but they can also contain extensions to the build system. So right now, there's a few of these in Meteor already. Things like CoffeeScript or Less or Sass. So these are packages that actually contain build plugins that they extend Unibuild by adding a new compile rule to use make terminology. They say, oh, if you encounter a file that ends in .coffee, run it through this process, which is arbitrary code inside this build plugin, and then inject that right into the bundling process. So, and these plugins know how to participate, for example, in source map processing, so the source maps will get chained together as necessary. Right now, it's not actually necessary. So that is what we've done so far in Unibuild. In the future, there's a few other parts of the Unibuild pipeline that are still fixed function. So minification is just something you can turn on or off, but you can't customize. It's built in. You couldn't have added minification if it weren't already there. That's something that eventually, I don't know in what time frame, certainly post 1.0 will change. So minify will just be a plugin that you can, a package that's included by default that is a source-to-source transformer that inserts itself as a later stage in the build process. There's a lot of interesting things that become possible when we have these packages that hook into the build process. For example, automated test coverage analysis. Some really cool things you can do if you post-process all the JavaScript you've generated to add a little bit of code to instrument, say, oh, this basic block ran, this basic block didn't. That lets you do automated test coverage analysis. So definitely a very exciting frontier for Unibuild. Are we out of time?
Yep.
All right. Thank you, everyone. Yeah.
All right, next up, Justin. Oh, do you want to come over here? That way you can. Yeah.
Hi there, so I am Justin, and I've been doing some work on Meteor, specifically experimenting with Redis support. So I'm going to start off with a demo that should hopefully be very familiar to all of you. It's the to-dos example. And you can see that it works basically just the same as it always does. But what's new about this is that, of course, it is backed by Redis. So you can see that all those documents are actually stored as Redis keys, and we can get one of them. Here we are. So I wanted to talk very quickly today about what I was trying to achieve and sort of some of the lessons and some of the questions. So why Redis is the obvious question to ask first. So Meteor today is really just about Mongo. And the question that I had was sort of how hard would it be to add support for other databases? And Redis seemed like a good one to start with because it has really good change notification support as of 2.8, which should make it easy to do some of those live updates. The good news, as you saw from the demo, is that it works. The really good news for people that are building apps is there are almost no code changes. Like at the moment, you just change from a Meteor collection to a Meteor Redis collection. The bad news is there are lots of open questions, which I would love your input on. So the big obvious one is that documents, though Redis is a key value store, Mongo has an abstraction of a collection of documents. So it's not obvious how to map a collection of documents into a key value store. What I've done, as you saw before, was basically encode the collection and the document ID in the key and put the value as the JSON encoded document. That works. It's not ideal. It's not very performant. So one of the questions that's very open is, should we use a different strategy? Redis, in particular, has hashes and sets, which might be better but aren't obviously so better. Currently, the Redis experiment supports the same Meteor and Mongo filters and queries. So the code is completely unchanged. The bad news is that it's incredibly inefficient. In order to do that, you have to fetch every key, fetch every document individually, and run the filter using the mini Mongo code. That is very slow, really wouldn't scale, is only useful as an experiment, really. So it tells us that we want the database to run the filter for us. But maybe we don't want to support the Mongo query language. Maybe we should have a different query language. The obvious downside is do we end up with a query language per database? We have Redis, MongoDB, SQL, Cassandra, DynamoDB. Are we going to have 20 query languages? The other good thing is that the Mongo query language feels quite nice in JavaScript, so it might be nice to keep that, but I'd love input. Good news, the Redis live update, Redis key space notifications works very well. There are a couple of quirks about always having to fetch the document and some fake operations, but that basically works and is great. So in conclusion, alternative databases are very possible. Something I was pleasantly surprised by was how well everything was architected and how easy it was to plug in Redis, even as a quick hack. Redis itself is unlikely to be a great production alternative, but what databases would you like to see? Is it SQL, Cassandra, Elasticsearch? Is it other data sources that are maybe exposed as APIs, like Twitter or Facebook or something like that? So that's over to you. Please come and find me afterwards if you have any questions. Thank you.
Questions?
Oh, or now. Hey.
I can see the Redis store being a great session, but
Ooh.
on the server.
That is a good point. Yeah, where you're not running the full queries.
Right, you have this reactive data source. It's just a key value store on the client, and just using that on the server. I think a lot of people could get used to that.
Sorry, so the question, by the way, was about using Redis, particularly for the case of the session store. And that is, I think, a great idea.
Are you talking about abstracting the mini Mongo as a query language for any database?
So the question was, am I talking about abstracting mini Mongo as a generic query language for any database? And certainly that's one of the approaches that could be taken, and that's what I did here for Redis. So I take the mini Mongo query language, which is basically the Mongo query language, more or less, and using the same mini Mongo code, I was able to run it against Redis, the documents that are stored in Redis. And that approach would work for any database, but because it's not native to the database, it has that overhead potentially. So for Redis, that overhead is basically intolerable. For other databases, it might be more tolerable, but maybe we want.
Could you create a mapper?
You could definitely create a mapper, but I mean, you can't create a mapper to Redis because there is no real query language underneath it. But yes, you could definitely create a mapper, for example, to SQL, where you were able to push down a lot of those predicates down to SQL and have that be a lot more efficient. But then the question is, do you want something that looks more like SQL, or do you want to be using the Mongo query language with SQL? And that's a question for the community, I think. when you say that Redis is not, or the work you did is not likely to be a production alternative, that's specifically referring to the fact that supporting, complex queries doesn't perform well. Like if you were imagining, I was thinking of making this app with Redis, and the data model is a good fit for Redis, and now I want to use it with Meteor. Like you could imagine a Redis backend, just if you know going to it that it only supports Redis style operations that could perform well. It could work. The big issue is that if you have like 1,000 documents in your collection, you're going to have to do 1,000 queries every time you get that collection. And so there's no way to do just single document queries. If you know that your documents were single document queries, I have implemented that optimization. But for the generic case, it's going to be a poor match. But basically, for the case of any app you write in Redis in the first place, you're going to be writing single document things, right? Hopefully. But then again, now we come to the question, like, should we support a specific mapping for Redis in that case?
Yeah. One question from Twitter. Oh. They say, I'd like to see MySQL. It has binary log, which could act as Mongo's oplog. Is MySQL in the plans?
I think that's a great idea. And I will, sorry, the question was, is MySQL in the plans? And I think that's a great idea. They have, there's been log support, so yeah.
One last question.
I put in a vote for Elasticsearch. Elasticsearch has a lot of features search-wise if you're doing a lot of heavy search stuff that Mongo just doesn't have.
Yeah, I think so. There was a vote for Elasticsearch, which I think is a great one, very similar to Mongo in terms of the model, and has great full text search as well as nice predicates.
Oh, thank you.
Thank you.
Next up, we have Steve Cannon, also known as Steve with 2 E's. Last time he presented Ether POS, and today he's going to be showing you sine wave. Oh, I get it. It's a pun.
Yes, it is. There we go. OK. Hello, everyone. Like last month, I presented Ether POS, and it has automated 90% of my business's business processes. And I was really inspired by all the talks at the last Devshop. And I said, you know what? I'm going to go see what I can do to tackle our next biggest problem. And our next biggest problem is paper. We produce about 120,000 sheets of legal documents a year, probably more. It's about 14 trees. The tattoo industry does about 53 million sheets of paper a year, about 6,400 trees. So in 21 days, between using Iron Router, the Discover Meteor book, and various packages, I built SineWave, which has automated our release form management system. So you can sign up at biz.sinewave.com, and I'm going to log in. Can you guys see this? So when you first log in, you would create a waiver template. So I'm going to create a template called Meteor X Rocket Rental Waiver, because you guys merged with SpaceX, OK? OK, so I create it, and it puts me into a drag and drop editor real quick. And I'm going to drag over this thing that says Solar System Limitation Agreement. Your initials agree to not leave the solar system. OK, I'm going to delete this one. And it's saving the form while I'm doing this so I don't lose my changes, kind of like Google Docs. And I'm going to drag over a customer, drag and drop, the customer. This will automatically create a user and a customer record, so a user in the database, right? And I'm going to make you take a picture of the rocket before you leave to make sure there's no damage. Right? Oops, sorry if I got typos in there. I know I'm under a time restraint. And a signature. OK? And the last one will be a payment. And that's going to be admin only. Oh, God, I'm running out of time. OK, so, and if you go to, if anyone wants to go to that URL right there, there's the form. You guys can go fill it out. Uh-oh, out of time. I sign my name.
You're not a rocket.
I am not a rocket. And someone who's working at the counter sees that in the pending. They look through it. They say, everything looks great. We're going to charge you $60 because you rented it for a half an hour. And this time, I don't have to have the card like in a form field. It can just detect, at least it should detect. And there it goes, see it processing, produces a receipt. And I sign it, or I hand you the tablet, you sign it. You click Save. And then I complete the legal waiver, and it's now in the completeds. It'll take a minute to load it, but there it is. There's a completed one, archived forever. And we've already got, like, besides my chain of stores signing up, we've been live for 1 day. We've got 6 or 7 other studios signed up, 2 outdoor adventure places, and a yoga studio. So. And that's the packages right there that I used. Those are the shoulders of the giants I stood on. Thank you, guys, right? And like last time, even a caveman can do it, right? Okay. Any questions? It's pretty straightforward.
Oh, one guy back there.
Yeah, go ahead.
Was the camera functionality a package that you used, or did you?
No, it wasn't. It was really difficult, actually, to figure out. Safari was frustrating. Oh, was the camera package a package that's in Atmosphere? No, it was not. And it was difficult to figure out. I ended up finding on GitHub, Adi Asmani, the guy from Google, has a Get User Media thingy, you know, and I use that. And I think that's really what they use in Google Hangouts, because it has the facial recognition, too, that you can use. And then for Apple devices in Safari, you have to fall back to that weird input type equals file, something camera star. It only works on those devices. It was weird. So a little kludgy. Yeah?
How did you scan your card? How did you get that into?
OK, so he asked how I scanned my card. So a lot of these card reader things are just dumb, right? They just dumped raw ASCII text. That's really how they work. That's how Nordstrom's and Target got hacked, right? Now, this one, they did RAM vector attacks on them, right? They did RAM scraping. That's what happened there. This one in particular, though, is kind of neat. This thing does, when it gets plugged in and powers up, it gets a public key, an AES key, right? And it encrypts the swipe data. But the swipe data, I mean, if you really want to see it, if I got a little time here, I mean, you can get one of these that's clear text or encrypted. It's up to you. Clear text is fun because you can swipe people's IDs and see all of the data. There, see? There it is. That's how they all work. There's nothing magical about them. Now that's encrypted on that one there. Okay, there was another question back there? Oh, OK, yeah. Yeah, these things seem magical, but they're not really.
So you put that in like an input field somewhere hidden on the screen?
Yeah, that's a good question. I don't remember what I do. What do I do with that? Yes, I put it on a hidden field. That's correct. I have to listen to it on the window, right? And then what you do is you look for the start sentinel and the end sentinel, right? When you see that flowing through, you capture it all, you put it in a hidden input field, and then when it's submitted, you process it. I have to send it to Heartland through what's called their Portico gateway. Yes?
So you used that same code, I think, for your other app as well?
I did, yes. He asked, did I use the same code for my other app? I did, absolutely.
Is that something you pulled out for others to use?
I have to ask Heartland if I can. You have to actually have your application certified. You can't just use it and start processing against them. You have to go through this whole certification process. They make you do a whole bunch of different types of test transactions and scenarios, because they have dozens of different types of transactions and scenarios, like tips and adjustments and weirdness. Any other questions?
There's one question from Twitter.
Yeah.
How long did it take to implement?
OK, so I cobbled it. The question was, how long did it take to implement? I was inspired at the last Devshop. And sitting right over there, I cobbled together about 25% of it, which was really just kind of, you know, like the bootstrap layout kind of stuff, you know what I mean, and all of it. I've spent about a couple hours every day for the last 21 days. It took 21 days to build this, and we're paperless now. Okay. Now, I think I emailed you when I was done, like last week, right? And every day I do a little bit of work on it, but yeah, 21 days. And I think everyone should try that, you know, see what you can build in 3 weeks to solve a really big problem. Because it's possible, right? a tattoo artist can do it, you can do it. Right? Right?
All right, next up we have Tim Haynes, and he's going to show you Respondly.
Glad I didn't follow that.
All right, you have Thunderbolt. There you go.
Respondly. So I don't know, you said you were glad you're not following this. I thought your thing was really impressive, 21 days.
I don't know, I've been using that for the last week and it's amazing.
We've been working on Respondly for over a year now. It's a team inbox for email and Twitter. We built it with the initial use case of supporting customer support. I had another business called Favster, still have another business called Favster, which has 3 million users using it each month, and they asked me lots and lots of questions on Twitter and lots and lots of questions over email, and we didn't really have a good way of handling that. We tried a few systems and we thought we could build something we liked a little bit more. We had a few other people agree with us, Tweetbot, Stripe, NPM, Pocket, and another company called Slack are using it now. And really, I just want to show you what the sign-up process is like. So I'm signing in. And my team, so it's all about team communication with consumers out there. Some of them might be your customers, some of them might not. They might just be firing you questions. So we have this little tour the first time that you sign in. It basically helps you get going. You add your company Twitter account. It's not Tim Haynes, it's Meteor Demo Inc. And one thing it's really good for is monitoring searches. And there's a couple of email steps too, but I'm going to skip that for this demo. And so that's the admin setup. The first person who sets up the Respondly gets that. And then after that, there's like a quick 7-page tour for people who, other team members who join, they can learn more about how it works. I'll just skip through these. But yeah, if you want to use it, they're kind of interesting. So what happens is that we end up with conversations in our inbox here, and it's built to be used really fast, so we've built in a whole bunch of keyboard shortcuts for it, so it can be totally driven from the keyboard. Here's a tweet from Meteor talking about Steve being up to speak, and wow, that was pretty awesome, so I want to favorite that. Yeah, I can do that with the F key. I can follow Meteor with the W key, and when I'm done with that, I can archive it just from the keyboard. And what that lets me do, we've got a lot of companies who are sort of receiving 50, 100, 200 tweets a day, and this lets the whole team work on it and basically go through and process those support queries really quickly. That's it, time.
Questions?
So do you have any customers? Who's using this?
Yeah. Do we have any customers? Who's using this? So we launched it in April the 15th, just recently. But we've got Stripe using it, we've got Pocket using it, Slack's using it, Tweetbot's using it, which is kind of funny because their whole business is around a Twitter client. And I use Tweetbot for a personal system, but this is really good for running a business with business Twitter account.
Any plans to support other social networks?
Yeah, we've got a list of plans. It's about this long, and somewhere in there is like Facebook and LinkedIn and a few other things. But yeah, Steve.
Yeah, how do you do the team organization and keep the data together?
How do you mean? What do you mean exactly?
You add people, right?
Yep.
And you're basically giving them access to the data, but they're not fully in charge, right?
It depends. You can make them an admin,
Okay.
and then they are fully in charge, just the same as you are. They've got all the rights that you have. Or you can just make them a team member. Also, after you've added someone, you can control what rights they have. So do you really want to let them retweet from your main business account?
Yeah.
And you can say only admins, or no one can do that, or everyone.
Do you use a Meteor package to handle that? Or
Yes. We're using about 54 Meteor packages that we build ourselves, and 4 open source ones, and then the Meteor stack. Yeah, but I guess a lot of the UI is custom built.
Slava?
Can you tell us more about your scaling experience? How many servers do you have? How many customers?
Yeah, I don't know. That's a long topic. Can I talk about scaling? And yes, I could, but not in the time we've got. Do you have a question?
Yeah. Did you use a package to do the social logins at the beginning? I'm assuming the Twitter login in particular, you're going to use those Twitter credentials from the server side to pull Twitter messages.
Yeah, so we're using the Twitter Meteor package, and the login utilizes that, and then we just customize it a little bit. So we've set it up so that you can add multiple business accounts that you want to manage, and that's leveraging the Twitter package, but it's got some custom callback handlers on it which stick it into a different collection on the server when it comes back.
I think it's such a great Twitter package.
Yeah, it's delightful.
Cool, thanks.
Thank you.
All right, next up we have Josh Owens. Josh is from Differential, and by the way, nice shirt. And he's going to be telling you a bit about the testing initiative that is starting to coalesce, and it's called Meteor with a side of cucumber.
All right. Whoops. So, Meteor with a side of cucumber. I am Josh Owens. You can find me on Twitter. You can find me on GitHub. Created Creator.io with Telescope. Pretty awesome. Ryan and I do the Meteor podcast every week, meteorpodcast.com. And then we build full-time packages at differential.io. And I guess about a couple months ago, we decided to write a testing book. I don't know why. We missed testing and really wanted to get back to it. So decided we'll write a book. Like, let's just wing it and see if other people are interested too. And it turns out people are. So we kind of got involved with that. The other thing is we wanted to build an app called Microphone, kind of like Telescope or Microscope. And it's for podcasting. So we've been doing that like lunch and hack once a month, just building an app live an hour at a time. And I think we'll get it done the next hour. So it'll be about 3 to 4 hours total into the app. And we're using that as an example for the book. So what is Cucumber? Cucumber is a syntax that allows you to work with business development people or project managers, product managers. They can write simple English syntax that translates into testing steps that you can automate to test your app. And then the other piece of this is velocity, and there's going to be a talk next month where Sam is going to go into more detail about what velocity is, but you'll get to see it here in a second. It's a test runner that allows you to use a framework, and you can just say like MRT add Cucumber in this instance, and it'll install it and start running your test for you. So let's see what that looks like. Did a little video so I don't have to type. Oh, it looks horrible. All right, so up here in the top, you get this little dot, and that's the test runner live in your app. And then
you can't read this, but there's a feature at the top. Oh, there we go. And then a scenario at the bottom. Whoops. Oh, flip forward. All right. So there's the test runner dot. And then the feature is the kind of like the description of what it should do. And then the scenario is like the individual step. So like the edge case or the corner case that you might be testing against. So in this instance, given 3 episodes exist, when I go to the home page, then I should see 3 episodes with titles. And so at first I had it at 4, changed it to 3, and you can see like it automatically updated, very reactive, very Meteor-like, updated the web page. Let me pause this. This is a little more explanation here. And these are the steps that are hooked up. So in the scenario you saw before, I said, given 3 episodes exist, when I go to the home page, I should see 3 episodes with titles. So what we're really doing is we're destroying any episodes we had, creating all the episodes, and then we're done with that step. So we issue a callback, and then the next step, we go to the home page, and then the last step, we check. We use Zombie here, which is like Selenium or Phantom.js or something. And we query for all the H3s that are inside an article. And then I'm just checking that I see the right number. And then if I get the right number, I just issue a callback. If I see the wrong number, then I issue a fail, which causes the test to fail. So I guess that's about it. It looks like I'm out of time. This stuff is all brand new. Can't advance slides. You can see like Cucumber, it's only had 6 downloads. Velocity's had 50 downloads, so this is all brand new, and we're still working on it. But you know, we think it's good so far. And if you're interested, we've got a book. There's 3.5 chapters on testingmeteor.com. Sure.
Question mainly about Cucumber.
Mm-hmm.
Have you actually seen business people actually use it?
I have, yes. So the question was, have I actually seen business people use Cucumber? So I've been using Cucumber. I came from Railsland and been using Cucumber for a long time. Probably the instance where I've seen it work most with business people are when I've worked in individual companies that were building one product and they had a product manager. In the client world, it hasn't worked out so well. They usually don't have that kind of education on, you know, thinking through, I guess, the steps in that way. So usually we'll have someone like a project manager kind of helping them work through that. Sure.
I tend to use both Cucumber and Jasmine tests. Does Jasmine work with Meteor?
So the question was, does Jasmine work with Meteor? Actually, Sam, the guy that wrote Velocity, and has been kind of leading the Velocity group, he wrote RTD, and he's been working on Jasmine Unit, and that also works with Velocity. So yeah, you can use Jasmine. Sure.
Do you have a plan? When are you going to release the book?
So the question is, when are we going to release the book? So tentatively, it's like June, end of June, beginning of July, August. I don't know. Like, you know, I'm working hard on it, but there's a lot of like discovery going on. Like, I was literally the first person using Cucumber, and there were like 5 things broken, and they've been fixed, and it's great. But you know, at the same time, like there's very little documentation on a lot of the frameworks, so it's really just a lot of discovery and learning at the same time as writing. So.
Do you still get early access?
Do you still get early access? Yes, right now, if you go to the testingmeteor.com, you can purchase it. It's $29. You'll get the book delivered right to your email. If you put in your GitHub username, you'll actually get access to the repo, and you can follow along as we're developing it. I push a couple times a week, so yep.
Thank you.
All right.
Next up, Dan Daskalescu. And while Dan is setting up, I'm going to, if you bring your laptop over. While Dan is setting up, use.
You want to do it on that, right?
Yeah. Okay, cool. before Dan starts, there was a question on Twitter, where can we get that Discover Meteor t-shirt? The answer to that is if you're going to HTML5 DevConf on Thursday, find other Meteor people, and we will have some shirts with us. All right, Dan Daskalescu.
Thank you. Hi, everyone. My name is Dan Daskalescu, and I'd like to share with you a way to structure your apps without much code change that will make them faster and more robust. I'm working at the moment on 2 apps. One is Stockbase, which is a financial information portal for value investors, and my friend here, John, is founding it with me. Basically, we aggregate a lot of feeds, and we show the interesting articles for you. So that's a lot of external data intake. The second one is My Date Spots, which shows you interesting places to go on dates, basically like Yelp minus car mechanics, law offices, doctors, dentists, whatever. But you can't just get Yelp data and filter those out because it's copyrighted. So how do you start with a good initial data set without having a lot of users? Well, you can get data from OpenStreetMaps if you come up with intelligent queries for it, like, let's say, which benches are less than 50 feet from a river, a lake, or the ocean, okay? That might be a romantic spot. So you run this query on OSM. It gives you back a bunch of benches, those circles there. So again, lots of data intake from the outside. The problem is this API is slow, and geodata can be large. So if you do this in your app, your front end is going to suffer too. It might be slowed down, it might be crash. Unless you structure your app in such a way that you separate the backend from the front end. And that's the trick. And you notice the backend is fatter because that's where you stuff. Everything doesn't belong in the front end, right? So front end will only deal with the UI and subscriptions, and the backend will do all the heavy processing. And they communicate via MongoDB. Later you can use DDP if you want to, but as I said, this is a very simple way to start. You separate your code in these 2 Meteor apps, and they communicate via database without much in terms of changing your code. And this lists a number of interesting advantages. This is the admin UI for the backend if you want one, but usually your backend can just not have any UI. So first, while you develop this, you can restart things separately. Okay, so while you restart your front end, your backend will not have to stop downloading its feeds or getting map data. Then, if they crash, they're not gonna crash in tandem. So your app has a lot of uptime, and the backend cannot bring down the whole system. Then again, the backend will use a lot of CPU cycles. I'm not sure what's so funny about CPU cycles. But that means your front end can be responsive, can service subscriptions separately because Node, as you know, is single-threaded. And this helps you just be smarter, especially if you have a multi-core machine. Your front end will be more responsive. Then as a bonus, in Meteor, you don't get separation between templates. So if anybody peeks to your console, they can see all your admin templates. Not if you separate the 2 apps. So the admin template will belong to the backend UI, if you have one. The front end will only have the user visible interface, so they can look there as much as they want. That's basically it. Thank you.
Questions? All right, thank you.
Thanks.
app, but I've actually been upgrading it throughout time. To keep up with the different versions of Meteor. So now it's all on 0.8.1.2 and Blaze and all that stuff. So basically, I'll go through PegLeg real quick. PegLeg, actually, I'm a filmmaker. I have a lot of friends who are filmmakers trying to distribute their films online. And a lot of them use YouTube. And people were watching these films on YouTube, and they were kind of hard to find. So I was like, OK, I'll make an app where it's easier to find films that are on YouTube. So basically, here I have a list of all the films that have currently been submitted. But if I were to look up one that Jade recommended, which is a really good one, World Builder. So this is tied into the TMDB database as well as uses the YouTube API. So basically what happens is you search for any film. You'll see a YouTube search result list on the left-hand side. You can go through these search results. Luckily, the first one is actually the film, so then it'll actually play the film. Once you are convinced that this is actually the film, you can upvote it. So it's totally anonymous, but the community kind of upvotes things, so it's crowdsourced in terms of like the quality of the films that are on there, whether they're real or not. Enough downvotes and it'll disappear, as well as if it disappears off YouTube, it also disappears the next time somebody tries to watch it. So if I hit yes, that becomes a film on there, and then it'll reactively add to that homepage. So it'll be one of the films that's viewable on that homepage. Anybody can view any of these films. And yeah, it was a lot of fun to build this app. There's other ways to add films, like if you know the link, like somebody sent you the link, like this one for Portal. I could just take this link and go into the Portal page, which is this guy, submit that link, and then it'll add it as well. Pretty trivial stuff, and then you can just play it and enjoy. A lot of the cool stuff about this app just like was actually tracking along and keeping up to date with what's going on. Originally, the cool thing about integrating with Blaze was that I got to remove a whole bunch of code, which is like a perverse pleasure that a lot of us coders have. So you get to like delete, isolate blocks and stuff like that for the YouTube video, which was, it was really tricky in early days to get that to work, but now it's really cool. One of the hardest things to implement was, a lot of videos on YouTube are split up into like separate pieces. Like this film Showa is like, it's 8 hours long or something like that, and it'll be split across, 10 different parts. And how do you combine all those parts together? But I've written some code that'll go through, find all the different parts, combine them into a playlist, and then you can just watch it seamlessly. Okay, I'm out of time. That was it. TMDB I use for all of the stuff that you see here. So basically all the search results plus all of the images and the metadata for the films. I have filters all throughout, so you can see here 2007. If I click 2007, I'll go back to the home page and just see all the films that have metadata for 2007. And then for my friends who are filmmakers, I try and convince them to submit their films to TMDB so that that data is in there as well, since it's an open database.
Do you have any kind of like rating system or a way to see that kind of metadata?
Do I have a rating system? No, not currently. I have a whole Trello board full of stuff that I want to implement, including like a TV UI and totally tricking out the UI to make it a lot more usable and stuff. But slow and steady. It's actually more. So far, it's been a bit of work to just like track with the new changes in Meteor, so that's like, apart from my day job, that's what I'm actually, when I get down to PegLeg, I'm like, okay, what do I need to fix now? It's been good though. It's been a lot of fun, a great learning experience. I teach Ruby on Rails, and I often encourage Meteor as the next step.
What's your favorite movie?
Back to the Future. No questions. Anybody else? Nope. Cool.
Thank you. Awesome talks. By the way, we're going to have some social time after, so if everyone could grab the seat that they are currently in and stack it up against the wall, that would be super awesome of you guys. Thank you. And to our friends on YouTube, don't forget to subscribe to the channel. The button is right here. And yeah, see you next month. Oh, that's right. HTML5 DevConf is on Thursday. If you want a Discover Meteor shirt, you can find Meteor folks at HTML5 DevConf.
David has a talk at 2:30.
David has a talk at 2:30. Thank you, Prompter Alice.